Welcome back, everybody. So let's talk about a concept related to definite integrals, not net area, not signed area, but total area. Let's try and calculate the total area between the graph of f of x equals sine x on the interval 0 to 2 pi. And as is often the case, let us start by getting a little sketch going. Here is sine of x going up, down, and then up again, changing concavity at x equals pi. Now the difference between total area and net area is that net area treated regions under the x-axis as if they had negative area, whereas total area treats both of these regions as contributing positively to the sum total of the area. Since total area and net area are different in this case, we're going to have to be careful because we will not be able to use the definite integral directly to answer this question. This is not the answer, because this would give us not total area, this would give us net area. The trick that we do to transform this definite integral from a total area calculation to a net area calculation is we split this up as two separate calculations. I'm going to take not just one definite integral, but two definite integrals. One integral I will take from 0 to pi, and the next I will take from pi to 2 pi. In the case that the function is above the x-axis, so that the definite integral would give me the correct result, I will just take the integral of the given function sine of x. But on the range of x values from pi to 2 pi, where sine of x is negative, I'm going to counteract the fact that the definite integral will treat this as a negative area. I will counteract that negative and cancel it with a second negative sign. My hope is that by counteracting this negative area with another negative sign, I will get a positive area for this region, as I am looking for total area. Both should be positive. So let's go ahead and let's find our favorite antiderivative. Antiderivative of sine of x is negative cosine x. And we're going to evaluate that from 0 to pi. And the antiderivative of negative sine is cosine. And we're going to evaluate that from pi to 2 pi. Plugging in pi to negative cosine x will get me negative minus 1 or 1. And from that we will subtract negative cosine of 0. So subtract negative 1, we get plus 1. In the back we have cosine of 2 pi. And then we subtract cosine of pi. So all in total, from this calculation, we get 1 plus 1 plus 1 plus 1. We get a grand total of 4. Complete positive total area, unlike the 0 net area that we would have found if we hadn't done this adjustment of flipping the negative part of sine upside down. Now, in general, we can summarize the process that we just did in the following way. If we want to calculate the total area between the graph of f of x and the x-axis on the interval from a to b, then we can integrate from a to b the absolute value of f of x. the absolute value of f of x. And this would involve taking multiple integrals. Taking an integral over the region where f of x is positive of the original function. And then taking the definite integral over the region where f of x is negative of the flipped function, change it from negative to positive by putting in a secondary minus sign. So when asked for total area, you have a couple of steps to do. Typically, I begin by graphing the function so I can see visually where is the graph positive, where is the graph negative. Calculate the definite integral of the original function on the regions where the function is positive. Calculate the definite integral of the opposite of the function on the regions where the function is negative. And then add up all those quantities. You're on the right track usually if you get a positive answer for total area.